Objective 9, graphing a function and its inverse. This section is just notes. You can copy this right into your packet. It's one simple problem. Again, we have a compressed time frame, so we're skipping through this issue so you can see it. It's not that deep. We have a function that's formed by joining two line segments with these 3 points. So we have a line segment from P0 to P1, a line segment from P1 to P2, and we'll call that F. Let's draw a graph. I'm going to draw a nice big graph here. There's X, there's Y, and on our x-axis we need a scale of 1, 2, 3, 4, 5, 6, 2, 4, 6. That's on the x scale, and the y scale, same thing. 1, 2, 3, 4, 5, 6, 2, 4, 6. And P0 is the origin. P1 is 4, 3. We're going to go over 4, up 3. And I'll write 4, 3. And then P2 is 6, 4, all the way over to 6, up to 4. If you have a piece of graph paper, you can do this a little more accurately than me. And then if you join these two line segments, there's one line segment, there's another line segment. We call this function f. Now the inverse is very easy. This function takes 0 to 0. The inverse has to take 0 back to 0, so that point doesn't change. You just switch the coordinates. So the inverse starts right here at the origin. This function takes 4 to 3. Our new function has to take 3 back to 4. So you just switch the coordinates. We go over 3, up 4, and that's right about here. And then, of course, switch the coordinates. 6, 4 becomes 4, 6. We go over 4, up 6. That's right about here. And you can connect the line segments. And there's F inverse. And it turns out if you draw a dotted line, y equals x. The inverse is simply the mirror reflection in this line. Okay, you can reflect f over that or into that line and it gives you f inverse. It's a very simple principle. And you can use this to construct all sorts of other functions. Given a function, you can construct a graph of its inverse. I'll just give you one simple example. Y equals x cubed looks like this. And it goes through the point 1, 1. And the point -1, -1. There's the x-axis, there's the y-axis. That's y equals x cubed. The inverse is cube root of x. Okay, what's the graph of the inverse look like? Looks like that. There's y equals cube root of x, or x to the 1/3. Okay, it's fairly useful, so you can use it to graph quite a few functions, given known functions. So we'll also come back, we'll see this principle when we talk about rational functions. We already looked at one rational function that is its own inverse, and I'll give you one more example. Take a quarter circle. F of x equals square root of 1 minus x squared. That function is symmetric in the line y equals x. It is its own inverse. You can follow through the process that we did in Objective 8, and you will get f -1 of x equals square root of 1 minus x squared. It's predictable. Whenever it's symmetric in the line y equals x, the function is its own inverse. So Okay, that's all for this objective.